Okay, and we're back again after we just helped Katie with her problem. Look, Katie, you were on YouTube. All right. So, what's the difference between disjoint and independent? Here's how it works. When you're talking about disjoint events, what you're talking about is one event. You're looking at, if we think back to this chart here, I'm saying you pull a card and these cards, the 2, the 3, the 4, the 5, the 6, the jack, whatever, they are disjoint from each other because they don't intersect. Red and black are disjoint, but red and 2 are not disjoint because they intersect. If we think about this as a Venn diagram, you're talking about, here you are, here's your red cards, and here's your black cards, and they take up the entire space, by the way. It's a crappy picture. But they take up the entire space. The cards red or it's black, they don't intersect. And there's this kind of thought that says that independent or disjoint events cannot be independent, because the philosophy is that if you don't pick a red card, what are you going to pick? You're going to pick a black card. So you're changing the probability of picking a black card if you don't pick a red card. That's kind of a crappy explanation as far as understanding goes. Here's what we're going to go with. Disjoint talks about one event. You're looking at one event and one event only. Is this card red? Is it black? Do they intersect? If they do, they're not disjoint. If they don't intersect, they are disjoint or mutually exclusive. But independence talks about from event to event. You're talking about more than one event. Does the first event influence the second event? That's independence. Independence talks about more than one event. Disjoint talks about one event only. Is there an opportunity for some sort of question in there to mess with you? Yes. Yes, there is. There most certainly is. But disjoint and independence are not the same thing. So if it says, oh, these events are disjoint, therefore they are independent. No, they're not. All right, just about done with the slides here. What have we learned? Probability is long-term relative frequency. Law of large numbers is for long-run behavior. Watch out for misinterpreting the law of large numbers. That's that law of averages, which is not a law. Don't say this is the law of averages, because there is no law of averages. It's a misinterpretation. What have we learned? We've learned about the addition rule and the complement rule and the multiplication rule, and something has to happen. And oh my goodness, we're done. Schwabba, that's amazing. All right, so here's what we need to look at now. We've got some example problems here that will give us a big help. And some of these are really, really fun. And some of them aren't. So let's see if this is going to open up here. As we have this technology weight. Oh, technology weight. Okay. Suppose that 40% of the cars in your area are manufactured in the U.S., 30% in Japan, 10% in Germany, and 20% in other countries. If cars are selected at random, find the probability that a car is not made in the U.S. So if I'm going to write this, let's get my pen out here. I've got my pen. I would say, what's the probability that this car is U.S. not, or not U.S.? There are two ways that I could solve this problem. One, I could sit there and say, oh, if it's not U.S., it would be the complement of being U.S., which would mean that it would be equal to 1 minus the probability of being a U.S. car. A U.S. car is 40%. It says so up here as this thing goes away. 40% of your cars are made in the U.S. So 1 minus that would be 60%. The other way that I could think about this question, I could say if it's not made in the U.S., then it is made in Japan, or it would be made in Germany, or it would be made in other countries. And or means and. So I can talk about this being the probability of Japan, or Germany, or other countries, and or means add, which would be 30% plus 20% plus 10%, which is going to be 60%. I can go across that question two ways. All right. Probability is made in Germany or Japan. Probability of Germany or Japan. Or I've got a Japan or Germany here, which would be Jorg. Or if I went the other way, it'd be Gorge. Or means add. So, because I'm increasing the probability of success here. I'm increasing the successes. Probability of Japan is 30%. 30%, so that's 0.3. Or means and, the probability of Germany is 0.1. Add those together, that's 0.4 or 40%. And yes, 0.4 and 40% are the exact same thing. All right, you see 2 in a row from Japan. How many events do you have? You've got 2. So I'm going to rate this as a probability of Japan and Japan. And I see the word and. And my first thought, because I'm wrong, is that, oh, and means multiply. No. How many events do I have? That's the important step you start with and. How many events do I have? I've got 2 events, because I'm going to have a car from Japan, and then I'm going to see another car from Japan. Now that's 2 events, and 2 events and means multiply. So what's the probability of the cars from Japan? 30%. And means multiply here. Probability of cars from Japan, they are independent. It's 30%. 0.3 times 0.3, 0.09. All right. Probability, none of, this is not Old English, it's supposed to be 3. None of the cars came from Germany. What does that mean? That means I've got a car and it is not German or Germanot. And I've got a car that is Germanot. And I've got a car that is Germanot. So, not German, and not German, and not German. And here, I ask myself, how many events do I have? Actually, we've got 3. So, more than one event, and means multiply. Not German. Well, the probability of German is 0.1. So, the probability of not being a German car is 0.9. So, it's 0.9 times 0.9 times 0.9, which is 0.729. All right. At least one of 3 cars is U.S. made. We're going to come back to that in just a minute. All right. Oh, blank space for work. All right. New software products are highly successful 10% of the time. Moderately successful 30% of the time. Slightly successful 20% of the time. And failures 40% of the time. What is the probability the new software product is at least moderately successful? Well, if it's going to be at least moderately successful, that means that it could be highly successful, or it could be moderately successful. And or is going to mean and. So I take a look at the probability of highly successful, which is 0.1, plus the probability is going to be moderately successful, which is 0.3, and add them together, you're going to get 0.4. What is the probability that a new software product is successful? Well, let's see. If it's successful, it could be highly or moderately, or it could be slightly successful. Highly is 0.1, moderately is 0.3, slightly is 0.2. Add them together, you get 0.6. But the other way I could look at this is saying, oh, if it's successful, that means that it is not a failure. So I could also look at this problem as being 1 minus the probability of it being a failure, and the probability of it being a failure is 0.4. So this could be 1 minus 0.4, which is 0.6. All right. This is a blank page. Oh, thank you. And here we have our last question. And what we're going to do is, because we're almost out of time here, we're at 30 seconds or so, so we're going to pause this right now and we will come back and finish this last one. We'll have a short video for the end of this.